before you came to pre-calculus, there were some things that you knew about triangles. Two really important facts are that if you know the triangle ABC, that the sum of those three angles is 180 degrees. The second fact that you knew about triangles was that if you have a right triangle, any right triangle at all, and you know the length of this side, the length of this side, the length of the two legs, and the length of the hypotenuse, then a squared plus b squared is equal to c squared. That's called the Pythagorean theorem. Now, those two facts we will use often, and they are very, very powerful. The new thing that you learned, one of the first things that you learned in pre-calculus about triangles were things about ratios in a right triangle. So there's the right angle, and let's say that this angle, we could call it something, maybe we'll call it A, sometimes we'll call it alpha or theta, we've given it a lot of different names, but it is called the opposite side. This other leg is called the adjacent side, and this, of course, we identified three trig identities. The sine of the angle is the opposite over the hypotenuse. Now, as long as this angle stays the same, it doesn't matter how big this triangle is. The opposite divided by the hypotenuse will be the same for every single triangle that has every single right triangle that has angle A. Because any enlargement of this triangle, this opposite over this hypotenuse will give the same ratio as this opposite over this hypotenuse. Two other important facts. The cosine of A is the adjacent over the hypotenuse, and the tangent of A is the opposite over the adjacent. Okay? Now those you've got to have memorized. And we have a suggestion for how to memorize those. So, TOA. You need to know those three trig ratios. Sine, cosine, and tangent were originally defined for right triangles. In a right triangle, for angle A, the opposite side is this leg, the adjacent side is the adjacent leg, and the hypotenuse is the other side of the particular angle that we're looking at. So this sine, cosine, and tangent were originally defined only for acute angles, angles that are between 0 and 90 degrees. Now that idea, though, gets generalized in the following way. Suppose that we take some acute angle, A, and pick any point on the terminal side. So we'll call this point xy. And if we drop the perpendicular here, we would in fact have a right triangle. Okay? And this length right here is whatever x is, that point on the terminal side, because x measures how far right and left you're going. This length right here, the opposite side, really has a length of y, because y measures how far up and down that particular point is, and this hypotenuse is the square root of x squared plus y squared, because that's part of the Pythagorean theorem. That allows us then to write each of these definitions in terms of x and y in the following way. Over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. Now that allows us then to generalize this idea to any angle now. No matter what angle we go to, just worry what the terminal side is. And on that terminal side, pick any xy. In this case, if we were down in this quadrant, both x and y would be negative. Then drop a perpendicular. The perpendicular always goes to the x-axis. So now we've got this adjacent side, which will be x. In this quadrant, that x is negative. This opposite side is going to be y. And of course, this is always going to be the square root of x squared plus y squared. Okay? Now, notice something. In the third quadrant, both the x and the y are negative. So the sine is negative, the cosine is negative, and the tangent will now be positive because it will be a negative divided by a negative. If we're over here in the fourth quadrant, then the sine is going to be negative because the y value will be negative. The cosine will be positive because the x value of any point in that quadrant has a positive value, and the tangent will then be negative in that particular quadrant. We carry this one step further. Suppose that we zoom in on the xy axis so that we're seeing the unit circle right here. And we consider our terminal side always ending on the unit circle. So our xy values are such that the hypotenuse is always 1. Then that makes these equations much simpler. It makes this one just equal to y on the unit circle. This one just equal to x. This one, of course, is still xy. This is in a very important trig identity. It's called the Pythagorean trig identity, and here's why. We know what this means is the sine of alpha squared. The order of operations here is you do the sine first and then you square that result. And this is the cosine of alpha squared. And that's going to be equal to 1. And here's why. The sine is defined as that opposite over the hypotenuse. So this is opposite over hypotenuse squared. This one is adjacent over hypotenuse squared. And we're going to try and show that that's equal to 1. Now, look at the right triangle. These are associated with opposite, hypotenuse, adjacent. And here's what we know. We know squared plus the opposite squared is equal to the hypotenuse squared. Okay, now this means that we've got the opposite squared over the hypotenuse squared plus the adjacent squared over the hypotenuse squared. That's got a common denominator, so it's going to be the hypotenuse squared on the bottom, and on top I've got the opposite squared plus the adjacent squared, and because of the Pythagorean theorem, I know that that much is equal to the hypotenuse squared. So this is the hypotenuse squared divided by the hypotenuse squared, and that's why we know this is equal to 1.